Hey everyone, go ahead and open your books to page 123. We are starting a new activity called Rates of Change, and then we're going to start in lesson 9.1. I'm talking about slope or ramping it up. So we have two learning targets. The first one is to determine the slope of a line from a graph, which we're going to focus on a lot. And then the second one is to develop and use the formula for slope. So I want you to go ahead and pause the video and read this paragraph to set up our scenario for today. What do we know? We know that Margot's grandparents are going to move in with her family, and they need to create a ramp. Okay. There are guidelines when we're building ramps and when we're building stairs. Both my dad and my brother are in construction. Think about the stairs in your house, if you have some, and how those are different than the stairs in a movie theater. Okay, or if you're thinking about a wheelchair ramp, we have ramps at the school, right? They can't be too steep because it's going to be really hard to push a wheelchair up there. And it could be quite dangerous if someone is flying down it. Okay? So, question 1. What do you think is meant by the terms rise and run according to these stairs right here? So if I'm looking at this picture in my book, I notice it says total rise. So think this is rise, 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 and then this whole part is the total rise. And then I can see where it says run. So this is probably the run part of my stair step, and it's from here all the way to here. So what do you think is meant by the terms rise and run? Go ahead and write down your answers. Some answers that I've received in the past are height or steepness of the step. Rise is up and down. Okay, so that would be vertical. Run. I've heard students say that this could be the width of the step or the length of the step. And our run would be horizontal movement. Turn your page to 124, and we're going to look at this graph. Notice how we have a line here on our graph, and then the book drew in stair steps for us. Okay, vertical change can be represented as the change in y. Vertical is up and down. So it makes sense that it's the change in y, because look at where your y-axis is on your graph. Okay, so vertical is up and down your y-axis. Horizontal change is from side to side, left to right. That's the change in x. So there's my x-axis. Okay. So what I would like you to do is take time answering question 2 and 3. Question 2 is all about vertical change. Okay, so between points A and B, I moved up 1, 2, 3 spaces, so my answer here would be 3. Then you're going to do the same thing between points A and C. Read carefully, and C and D. Question 3, we're looking at our horizontal change. So horizontal is side to side, left to right. 1, 2, 3, 4 spaces. Okay, when I was in elementary school, we had computer class, big old monitors, and we would go in and we would play this turtle game. And it was a math game, and we had to tell the turtle how to move from one spot to another. It was like a set of directions, and I would have to tell it to rotate 90 degrees, things like that. So if I was walking from points A to B, right, I went up 3 spaces and over 4 spaces. So my vertical change is up 3. My horizontal change would be over 4. So think about slope as a set of directions. How do I get from point A to B? Go ahead and pause and work on questions 2 and 3. To B, between points A and C. So from A all the way to C, it's a bigger stair step. 3, 4, 5, 6 spaces. C to D, 3 spaces. Okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8. So that answer is 8. This answer is 4. Now, could we count from points A all the way to D? Sure. Or from point B to D? Absolutely. We can find the slope between any 2 points on a line. This piece of information right here in your book is really important. Okay, this tells us all about slope. Slope is the ratio of vertical change to horizontal change. Right? So our slope equals vertical change divided by horizontal, which is the same thing as change in y divided by change in x. And then this symbol right here, this triangle, means the change in. So the change in y over the change in x. Right? You can also think about slope as the measure of incline or decline of a line. And when we move forward, we're going to use the variable m, the letter m, to represent slope. Question 4. Find the slope of the line segment. So what's the slope between points A and B? Well, we're going to use our answers from questions 2 and 3 to help us with question 4. Okay, so the slope is our vertical change. So how many did we rise between points A and B? It was 3. How many did we run? What was our horizontal change, our change in x? That was 4, so that would be my slope. Points A and C. We went up 6 over 8. Wait a second. Both of those things, both of these numbers are even. So this can be reduced. Simplify it. They're both divisible by 2, so we can reduce to 3/4. You are always, always, always going to reduce the slope if possible. We want it in simplest form, in simplest terms. Question C, between points C and D, 3 over 4 as well. So what do we notice about the slopes from 4A, 4B, 4C? I notice that after I simplify or reduce, they are all the same. All the slopes are the same. So what does that mean? What does our answer tell us about all the points on a line? It means that the slope between any 2 points is always the same. Your stairs, if built correctly, should all have the same height or vertical change and the same width or length, the horizontal change. That's what makes our graph linear. That's what makes our graph a straight line, is that the slope is the same between any 2 points. Number 7. Slope is sometimes referred to as rise over run. I'm going to use those 2 R words a lot, rise over run. Explain how the ratio rise over run relates to the ratios for finding slope. So if we were talking about the word rise, that would mean our vertical change. Which is also our change in y. Run would be our horizontal change. From side to side, which is our change in x. Question 8. Would the slope change if you counted the run, the horizontal change, before you counted the rise, the vertical change? Explain your reasoning. The slope will not change if you count run first or rise first. But what matters, what's really important, is that you must, okay, you must put the rise in the numerator. Okay? It's always rise divided by run. So I could count my run first if I wanted to, but it has to be in the denominator in the bottom of my fraction. Okay, so rise is always on top, run is on the bottom. Vertical change, which is our change in y, divided by our horizontal change, which is change in x. You can count whatever order you would like, but rise has to go on top, okay? All right, question 9. I see a line on my graph, and the directions tell me to determine the slope. Ooh, that was our learning target. But wait a second. I don't see any stair steps, and I don't see any points or any ordered pairs. So what I want you to do, okay, right now, is I want you to try to find 2 or 3 or 4 points on this line. The math tip box says select 2 points. Now, here's how you find your 2 points. Okay? You want to find a point that occurs at a good intersection between an x and a y. Okay? On these little tick marks on your lines, right? If I was aiming for the bullseye, it would be right in the center. So you want to find a point that intersects your y and your x perfectly at a whole number. Okay, don't try to find or figure out like what this point right here is, because that's a decimal. It's in between 7 and 8. We don't know what it is. So find points that occur right in the middle. So go ahead and plot points on this line. I see 3 different ones. I see this point right here, which is over 7 up 0. I see my y-intercept, which is 0, -3. And I see another good point over here, which is at -7, -6. So there's my 3 points. You can choose any 2 points here, and what I want you to do is count your rise over run and write it down. That would be our slope. If it helps you, go ahead and draw in your stair step. How many spaces did we move up? 3. So my rise is 3. My run, 1, 2, 3, 4, 7. Let me test that out for these other 2 points over here. Let's see if it's the same, because the book told me it's going to be the same. 1, 2, 3. Yep, we got the same answer. So it doesn't matter which 2 points you choose. We're rising 3. That's our vertical change in Y. We're running 7. That's our horizontal change, which is also called our change in X. Okay? Do me one favor here, and let's write out the ordered pair for this point. This ordered pair is 0, -3, because we're going to use that later on. This ordered pair over here is 7, 0. So write down in your book 0, -3, and 7, 0.